Good morning, boys and girls, and welcome to Math Mama Simone Sanaciro. Today's lesson is on exponents and powers of 10. Powers of 10. We're talking about the number 10, 100, 1,000, 10,000, 100,000. Those are powers of 10. They are numbers that can be written as products of 10. What does that mean? Products of tens, the first thing you need to know is what exactly is a product? Well, a product is an answer to a multiplication problem. So when you multiply two numbers together, the answer is a product. So 100 is 10 times 10. Or 10 to the second power. 1,000 is 10 times 10 times 10, or 10 to the third power. This in the box is a product of tens. It means I multiplied tens together. 10 to the second power, that's how we say that number, equals 10 times 10, which equals 100. 10 to the fifth power is 10 times 10 times 10 times 10 times 10. That equals 100,000. 10 to the third power, 10 times 10 times 10, and that equals 1,000. What do you think those raised numbers are? These small numbers, this 2, this 5, this 3. What are the small raised numbers and what do they mean? In the example, 10 to the second power, 10 is our base number, and the raised 2 is what we call an exponent. An exponent tells how many times the base, in this case it's 10, is multiplied. So when the base is 10, the number is called a power of 10. So in this situation, 10 to the second power, 10 is our base, our exponent is 2, so we would do 10 times 10. We would multiply 10 by itself twice. In one of my other videos, I think the one on place value, we talked about ways to represent numbers. So let's review that real quick. Standard notation is the most common way. It's the way that you see numbers written all the time. Expanded form is when we take the digits in a number and we write the value of each individual digit and we add them together. Word form is just that. We take this number and we write it using words. And now I have a new way to represent numbers. And that's called exponential notation. It's a number that is written with an exponent like 10 to the third power, or like we talked about earlier, 10 to the second power. So 1,000 equals 10 to the third power in exponential notation. 100,000 equals 10 to the fifth power in exponential notation. And 100 equals 10 to the second power in exponential notation. Now here I have a powers of 10 chart. This chart shows the powers of 10 from 10 through 1 billion, okay? Do you notice any patterns on this chart? So it talks about standard notation, which is 10, 100, 1,000, 10,000, 100,000, and so on. And then in the column product of 10, it shows that 10 is 10, 100 is 10 times 10. 1,000 is 10 times 10 times 10. So it's showing you how many times you have to multiply 10 to get the answer. And then the last column shows exponential notation. So I want you to take a look. If I can, I'm going to bring it a little closer up to the screen so that you can have a better view of the chart. Okay, so I want you to think about the chart, and I want you to notice if you noticed any patterns. Here's what I noticed. The number of zeros in a power of 10 written in standard notation is the same as the number of tens that are multiplied to give you that product. Wait, what do you mean by that? Well, in 100, which is standard notation, you are taking 10 times 10. There are 2 zeros in 100, and you are multiplying 10 twice. In the number 1,000, 1,000 has 3 zeros, so you are going to multiply 10 3 times. That's the first thing that I noticed. Did you notice anything else? The second thing I noticed is the number of zeros in the number written in standard form is equal to the exponent. So 10 to the 4th power equals 10,000 because there's 4 zeros. The exponent is 4. 10,000 has 4 zeros. 10 to the 6th power, which is 1 million, the 6, exponent 6, and there are 6 zeros in standard form. 10 to the 2nd power, 2 is the exponent. There are 2 zeros in the answer 100. Now sometimes numbers are represented as the product of a power of 10 and another number. So let's take a look at that. So if I had the math problem 3 times 10 to the 2nd power, okay, I could write it a couple different ways. 3 times 10 to the 2nd power, which means 3 times 100, or it could even be 3 times 10 times 10, because the exponent is 2. We multiply it by 10 twice, or we have 2 zeros in the power of 10, and that would give me an answer of 300. So you're taking the whole number 3, if you look here, and attaching 2 zeros. If I had the number 65 million, how could I write this number in exponential notation as a product of a whole number and a power of 10? I want you to think that, okay, what do I know? I know that product means to multiply. Think about, in the number 65 million, what whole number can I use? Is it important to know the number of zeros in my problem? I want you to pause the video and think about these questions. So in 65 million, 65 is our whole number that we're looking at. And if I count the number of zeros in 65 million, you'll see that there are 6 zeros. So that means 65, my whole number, times 10 to the 6th power, because there are 6 zeros, is going to be my answer. 65 million is also 65 times 10 to the 6th power. Again, you take the whole number, 65, you multiply it by 10 to the power of how many zeros are in the number. Let's try a few problems on our own. So I would like you to pause the video and write these 3 problems in exponential notation. Remember, you want to find the whole number, count the number of zeros, and use that number as your exponent. Okay, try these 4 problems on your own. I hope you guys did a good job with this. 26,000 equals 26, it has 3 zeros, times 10 to the 3rd power. 150,000, the whole number is 15, it has 4 zeros, so 15 times 10 to the 4th power. Number 3, 450. 45 is our whole number. There's 1 0. So 45 times 10 to the 1st power. And the last one, 24 is the whole number. It has 7 zeros, 240 million. So 24 times 10 to the 7th power. Nice work, boys and girls. So here's the hint that I tell my students. In the problem, 16 times 10 to the 8th power, you are going to write down the whole number. In this case, it's 16. And you are going to attach. Now notice I don't say the word add. I say attach the number of zeros of the exponent. So in 16 times 10 to the 8th power, I write down my 16, and then I attach 1, 2, 3, 4, 5, 6, 7, 8 zeros. Okay? Fingers are sticking. Okay. Boys and girls, I really hope this helped. Powers of 10, remember, write down a whole number, attach the number of zeros. It's the product of tens when you're dealing with powers of 10. If there's anything that you need help with, if you're not sure of something, reach out, send me a message, and I would be more than happy to help. If you have any questions, just let me know. Thanks, guys.